Hello, welcome to our channel. And to today's lesson, today we'll be looking at motion. Motion is defined as the change of position of an object with respect to time. There are four forms of motion. We have the linear motion or the translational motion. We have the rotary or circulatory motion. We have the random motion or Brownian motion. Then we have the oscillatory or vibrational motion. But today we'll be looking at the linear or translational motion. Now, before we start talking about the linear or translational motion, we must know that objects that a body that moves, they do so possessing speed or velocity. So today we'll be looking at the four equations of motion, which are right here, but we'll look at how it was derived or how they were derived using the concepts and understanding of the various parameters we have in physics. So we have V equals to U plus AT. We have V squared equals to U squared plus 2AS. And we have X equals to UT plus half AT squared. Then we have X equals to V plus U over 2. We have this. Now, let's start first with the basic foundations, the basic knowledge we have in motion. We know that velocity is the rate of change of displacement with respect to time, and that acceleration is the rate of change of velocity with time. And let's look at this. Now, a body at rest technically has a velocity of 0. Then eventually start moving, then it now attains a new velocity. So a body can be said to have initial velocity and final velocity. So to know the acceleration, you consider the difference in the velocity. So here we have acceleration equals to V minus U over T. Now, cross multiplying, we have AT equals to V minus U. We collect like terms. So when we collect like terms, we have U plus AT equals to V. So this will be equation 1. Equation then, that same equation 1, by the time we square both sides, we'll have U plus AT So by the time we square both sides, this particular expression now will square, let's say on the rough piece of paper, for instance, we have U plus AT squared. So we'll expand. We have U plus AT, U plus AT. So this will be U squared plus UAT plus UAT plus A squared T squared. This will be U squared plus 2UAT plus A squared T squared. Now, later on, we'll factorize here and here, so that we'll have U squared plus, bring out 2a bracket. Now, here we have 2UA, we divide it with 2a, we have 2UAT divided by 2a. 2 will cancel 2, a will cancel a, so we'll be left with UT. So this will be UT plus A squared T squared over 2a. This a will cancel one of this a, then we are left with a T squared over 2. Now, so here, that means This expression will give rise to this, but then again, we'll replace this with x. We'll replace it with x, so that what we'll now have will be u squared plus 2ax. So where we have this, we'll put this, so that this will now be u squared plus 2ax plus v squared. So this is equation 2. We must recall x equals to ut plus half at squared. So this will be another one as embedded in the equation which we factorize here. So x equals to everything here. Then we have that. Then for the fourth one, we'll go back to this here. So we must remember that there are two types of velocity. We have initial velocity and final velocity. So v and u. So for average velocity, v plus u over 2 plus average velocity. So the average velocity now, v plus u over 2 is equals to d over t. Then we now have v plus u over 2. So this will be the fourth expression, the fourth equation. This x for distance, So thank you for watching. See you another time. Next time we'll be meeting, we'll use this equation to solve different problems in motion. Thank you.